All right, welcome back to day 5 of our AI journey. Yesterday, we gave our AI a really clear roadmap, right? We gave it labeled data. But what happens when we just take the training wheels off? Today, there's no teacher, there are no labels, there's no answer key. We're going to see what happens when an AI is left completely on its own to make sense of the world. Let's dive in. So let's kick things off with this little thought experiment. Just imagine for a second you're in that room. 10,000 people, no instructions. How would you even begin? This puzzle, it perfectly captures the challenge and, the incredible power of unsupervised learning. It's all about creating order from absolute chaos with no rulebook to guide you. And that really is the core idea here. The AI is basically a detective, dropped at a crime scene with 0 initial clues. It just gets a massive, messy pile of data and is told, go find something interesting. Its entire job is to sift through all that raw information and start discovering these hidden structures and natural groupings all by itself. And this is what it all boils down to, right? The key difference. Yesterday, with supervised learning, the AI had the answer key. The data was labeled, and the goal was to make predictions. Today, with unsupervised learning, the answer key is gone. The data is completely unlabeled, and the goal shifts from prediction to just pure discovery, finding patterns we might not have even known to look for. Okay, so you might be thinking, why even bother with this? It sounds way harder. Well, it's simple. Because in the real world, the overwhelming majority of data doesn't come with neat little labels attached. Think about it. Every customer transaction, every social media post, all the sensor readings from a factory floor. Labeling all of that by hand? It would be crazy expensive and take forever. Unsupervised learning is essential because it works with the raw, messy data we actually have. So how does our AI detective actually crack the case? It doesn't just sit there and stare at the data. No, it has a specific toolkit. So let's open it up and take a look at the first 2 tools it uses to find hidden groups and some really surprising connections. So the first tool in the kit, and probably the most famous one, is something called clustering. And this analogy is just perfect. Imagine dumping a huge bag of mixed candy onto a table. Without anyone telling you the categories, what would you do? You'd just naturally start sorting them, right? You'd put all the chocolates over here, the gummy candies there, the hard candies in another pile. You just performed clustering. And believe it or not, businesses do this exact same thing every single day. They use clustering for what's called customer segmentation. They feed the AI all of their customer data, purchase history, what they clicked on, you name it. And the algorithm automatically groups them into these natural clusters. Suddenly you have bargain hunters, luxury shoppers, or loyalists. And now your marketing team knows exactly how to talk to each group. So how does this magic actually work? Well, the most famous algorithm is called K-means, and it's actually pretty clever. First, you just decide how many clusters you want. We'll call that number K. Then the algorithm randomly drops K center points, think of them like little magnets, into your data. Next, every single data point gets pulled to its closest magnet. After that, each magnet moves to the center of all the points it just collected. And you just repeat that process. Assign points, move the magnet, assign points, move the magnet, until the magnets stop moving. And boom, you've got your clusters. All right, so grouping similar things is cool. But what if our AI detective could find surprising connections between different kinds of items? This is where our next tool, association rule learning, comes into play. This is the secret sauce behind what's called market basket analysis. Supermarkets use this to sift through mountains of transaction data to see what people buy together. Now, some connections are obvious, right? Bread and butter, pasta and sauce. But the real power is finding the unexpected stuff. The classic and totally true discovery: on Friday nights, shoppers who bought diapers were also super likely to buy beer. That's a connection a human might totally miss, but it led to stores putting the beer aisle right next to the diapers. And if you want a modern example, you see this literally every single day. When you're on Amazon and it says, hey, customers who bought this also bought. Or when Netflix suggests a new show for you, yep, that's association rule learning in action. It's the engine behind almost every recommendation system out there. Okay, our AI detective isn't done yet. The toolkit has a couple more powerful gadgets inside. Let's look at 2 more techniques. One that's all about finding the odd one out, and another that can take impossibly complex data and make it beautifully simple. First up is a tool called anomaly detection, and its job is pretty straightforward, actually. It's all about finding the weird stuff. It's the process of identifying outliers, those data points that are so rare and different that they just don't belong with everything else. Now, the really clever part is how it works. The AI isn't trained on every possible type of fraud or every kind of defect. No. Instead, it just learns what normal looks like for a system. For example, it learns your typical spending habits. So when a transaction suddenly pops up at 3 a.m. from a different country, the system goes, "Whoa, that doesn't fit the normal pattern," and it flags it instantly. This is absolutely critical for everything from credit card fraud to spotting a tiny flaw on a factory assembly line. Okay, our last technique for today has a bit of an intimidating name, but I promise the idea is super simple. It's called dimensionality reduction. Just think about it like this. A photograph is a 2D representation of a 3D building. You've lost a dimension, you've lost depth, but you can still easily recognize the building, right? You've simplified the data while keeping the most important information. And this is where it gets just mind-blowing. See, real-world data is incredibly messy. You might have a customer profile with 500 different features or data points. Trying to analyze that is a nightmare. Dimensionality reduction can take all of that complexity, all 500 features, and compress it down to maybe just 2 or 3 core features that still capture the essence of what's going on. So why would you do this? Well, there are 3 huge reasons. First, visualization. You literally can't draw a graph with 500 dimensions, but you can easily plot 2 or 3 and actually see the patterns. Second, speed. Fewer features mean your AI models can train much, much faster. And finally, noise reduction. It gets rid of all the useless, irrelevant information and lets the model focus only on the signal that truly matters. All right, it is time for the final showdown. Let's bring it all home and put what we learned yesterday about supervised learning right up against everything we've uncovered today with unsupervised learning. This table right here just lays it all out perfectly. Supervised learning is all about making predictions using labeled data. Unsupervised learning is about discovering structure in unlabeled data. One has an answer key, the other has to figure it all out from scratch. So supervised gives you things like spam filters and price predictions, while unsupervised gives us customer segments and fraud detection. So to wrap it all up, let's do a super quick recap. Today, we saw that unsupervised learning is the art of finding hidden patterns in data that has no labels. We looked at the 4 key tools in our detective's toolkit: clustering to group similar items, association to find what goes together, anomaly detection to spot the weird stuff, and dimensionality reduction to make complex data simple. And just like that, day 5 is in the books. Tomorrow, on day 6, we're going to enter the world of neural networks. This is the brain-inspired tech that basically kicked off the entire modern AI revolution. Trust me, this is where things get really, really exciting. But before you go, I want to leave you with a little something to think about. Now that you know how AI can find these hidden patterns in pretty much anything, what's a pattern in your own life, maybe in your health, your finances, or even your daily habits, that you would want an AI to find for you? Give it some thought. I'll see you tomorrow.